Okay, hi everyone. So, welcome again. And today we are having module number 7 of the Global Professional Fellowship in Green Urban Innovation and Social Entrepreneurship. And today, the module entitled Circular Economy and Resources Recovery Adopting a Zero Waste Mindset and Practical Strategies for Reusing Debris in Reconstruction. And as usual, this module is being organized jointly by the Global Ambassadors of Sustainability, the Global Green Chamber of Commerce, and the Green University Network at the Kingdom of Saudi Arabia. So I'm inviting now Ms. Michelle Thatcher, the CEO of the Global Green Chamber of Commerce, for an opening remarks. The floor is yours, Michelle.
Thank you, Dr. Wassam. Thank you to our audience. I'm starting to see some comments coming in. So please let us know where you're joining us from today. As Dr. Wassam had mentioned, this is on circular economy, resource, and recovery. And this is our 7th module. So if you have not been a part of the first 6, you are welcome to go back and watch those so you can get your full professional fellowship. Or if not, you can receive your certificate for today as well. So here's just a few of the key takeaways. There's going to be some more, but we're going to learn that waste is a resource. And circularity starts in the design. Traditional materials still do matter, and recovery can become regenerative. And as always, please, we want to make sure that this is not just an academic only exercise, that we go out and we start taking action. So here are the steps and actions that each of you can take. Again, there will be more of those. And after the presentation, you'll be taking your quiz. So listen carefully because you want to make sure that you are able to take the quiz easily. And as we have been doing for the past year and a half, we're going to stop and give a moment of silence to give kindness, strength, and peace and love in the world that we know at times can be just very turbulent, both on a global scale as well as individually. And let's extend that kindness, strength, and love to our speakers today so they are able to provide us guidance in our journey for sustainable actions and helping us in our next career steps in life as well. I'm going to hand it over to Hajra to guide us on friendly reminders for our audience. Hajra.
Thank you so much, Michelle. Hi, everyone. Today, we encourage your participation. You're welcome to share your thoughts, reactions, insights during the presentations of our speakers. Please share your location where you're joining us from today. And please feel free to ask questions as the speakers give their presentations. Make sure to also list the speakers' names, and I will be collecting all of the questions. Towards the end of the presentations, we will have a Q&A session, so we'll bring all the questions in to the Q&A session, and if we don't get to the questions, the speakers will go back and reply to everyone's questions at a later time as well. This is an open, inclusive, uplifting dialogue, and we encourage your participation. We're looking forward to all the engagement today. Thank you. I want to pass it back to Michelle.
Thank you so much, Hajra. And one thing that I have seen happening quite a bit as well with our audience is there's a lot of networking, a lot of collaboration that's happening. So please continue to do that, as well as letting us know what actions have been taken and what successes have come out of any new relationships that are being formed, because we always love to share those here and then just learn more about what's taking place. And I'm going to give it back to Dr. Wassam. He has brought us all here today. He is such a shining star, and we are forever grateful to be partnering with him and the Global Ambassadors of Sustainability. So Dr. Wassam.
Yeah, thank you so much, Michelle and Hajra. And we start with our first guest speaker for today, Dr. Ziad Abu Nada. And Dr. Ziad, he is an associate professor and head of college at Central Queensland University in Australia. So the floor is yours, Dr. Ziad, and you have 12 minutes, please.
Thank you very much, Dr. Sam, and good afternoon for everyone. It's good evening here for me. Let me share my screen. I hope you can see my screen now.
We can see.
Okay. So thank you very much, Dr. Sam, and everyone who's involved in this very great initiatives. It's really an honor to be here and to present, although it's almost like 12 midnight here in Australia, but I insisted to be presenting myself rather than recording this session. And I do appreciate that there's really good experts attending this one. So in today's presentation, I'm going to just talk about the circular economy in the water. And I'll be having a case study from the Australian case in the Queensland state, a project that we have performed in 2023, 2024. And I'm just going to present some of the results about the perception of the circular economy in Australia. I'm going to elaborate a bit on the circularity of the materials and the whole circular economy status in Australia and give some statistics about what's happening here in Australia and how we do perform compared to some other nations. I'll be talking about the opportunities and challenges that is facing the current circular economy initiatives in the water sector in Australia based on this study. So let me start by, as long as we are talking about circularity, probably the circularity in the water is one of the, I will say, least aspects that has gained some attention in the recent decade. When we started to talk about circularity, we started to talk about circularity of materials rather than the water. And the circularity for the water started to gain more interest when we started to think about the water as a commodity and consumable rather than a source. In the circular economy of the water attracted this attention because we came to understand that the water is a unique element in the circular economy, where the water can be a source for other resources. So it could be a potential for energy, for waste, or even for some other resources and materials that can be used. And we look at the water as a unique commodity in terms of RPS, which is a resource, product, and a service. We can view the water as a product, or as a source, because it's the main source that comes from the nature. As a product, we can look at the water that there is a trade and there is a selling and buying in terms of the water. Virtual water is a very good example about how we sell and buy the water. As a service, it's definitely it's a service that we provide, and it's used to store and to produce some energy. So the water is unique because it can be under three categories together. It can be viewed as a source, as a product, as a service. And without consistent conceptualization, the decision makers and scientists and professionals will remain unable to understand how we develop these problems and solutions for the water if we deal with the water as one source, as a source, which is an infinite source that we use to understand or to conceptualize. Now, because we started to face some crisis and scarcity in the water, we started to look at the water as a product, as a service. And this is where we started to drive the understanding of the circularity. There are so many different definitions of the circular economy. And I believe that for myself, I do understand that this is probably the easiest and simplest and most appropriate way to understand how circularity, because when we talk about the principles of designing out waste and pollution, and we keep the product and the material in use, and then we regenerate the natural system. So it means as much as we try to attempt to reduce our access to the virgin sources it means like we are doing more circularity. Rather than having a good look at the end tail of the circular economy, I think the definition views that the circularity from the beginning is that you can conserve the resource as much as you can. Morcelletto et al. In 2022, they published a good article about the three principles of the circularity. They talk about three main things, which is the decreasing, optimizing, and retaining, which forms a systemized way of how we design the system. Decrease, it's mainly talking about decrease the exploitation of the source. So it's avoiding using water, avoiding using the source, reduce, or even find an alternative. That's when we decrease. When we optimize, if we have no other options than access the source, we need to look at the source, how to use it in a very optimum way, in a very efficient way, in order to make sure that the water, or like when we are taking it out of the source, we can change it or switch it into a different sources, energy, materials, recycling, reuse, and we keep it within the system rather than being out. Retaining refers to the strategies that we store the water in and recover the water from in a different economical value. So we will improve the value of the water. 1 cubic meter of the water in X geography probably is different in terms of its value than another similar 1 cubic meter in another geography. The difference in the value, it's not because the water has a different taste or color or specific or characteristics. It's just because the difference in how we can optimize or retain the water in the source. If we keep optimizing the 1 cube in X geography, it means like we added more values. And we will come to see in the next slides how the circle of these optimization can work in terms of a real example. The principles of the water system management are three. We are talking about design out waste, which is the first point in our definition, to optimize the amount of energy, minerals, chemicals, whatever we are talking about, and to optimize the use of the water with the sub-basins to use measures of the solutions. I will highlight the main important things because this is what is going to be highlighted in our study later on. So the first principle is to design out waste externalities, keep the resource in use it like more than once, regenerate, and try to recover the source as much as we can. I need just to focus on these three main elements, one elements at each principle, how we use measures or solutions which deliver the same outcome without using water. Can we replace the water? Can we use a different source rather than using the water and get the same results and the same outcome? Can we optimize the energy resources extraction from the water? Can we get more resources, generate some efficiency out of to optimize the source and get new energy, more energy out of the same cubic meter, so the cubic meter will make value in a more efficient way compared to another cubic meter that is just being taken, used, and then disposed. And then we talk about the insurance of the disruption to the natural water system, which is a social aspect, because the disruption, if you look at the water cycle in its own, if we look at it's a closed water cycle, which means like it's a reusable. There is a circularity in the water cycle by nature. What the human being have done, we intervened, we disrupted this water cycle, and that's why we started to talk about different disruptions and risks happening to the water cycle, because we wanted to shift the use and we wanted to probably, for some certain reasons or for some certain uses, we try to unbalance the water cycle from one area to another. This graph, which is again from Morcelletto 2022, is talking about the natural managed and the human managed circularity and how these three principles can work. If we look at the right-hand side, we talk about avoid, reduce, or use. The first thing we need to think of, avoid using the source. If we can't avoid it, then we need to use it more carefully. We reduce use. If we use it, we need to make sure that we will reuse it again and again and again in order to make sure that the cycle is really repetitive. And then the last thing, after certain cycles of recycling, we will try to replenish rather than dispose it as a waste. we need to replenish it by using this again as aquifer recharge or as any other like technique we can use. Now, where this is coming from, it's coming from re-optimize, where we have the adaptation. When we re-optimize things, it means like we try to put this in the same circle more and more and more. Now, in the principles of the circular economy as it was defined and how we create a value, as I said, how 1 cubic meter can be really more valuable than another cubic meter in somewhere else, we need to look at these 4 different diagrams, and then we need to understand what's the difference between each one. In the first one, we talk about something called inner circle, and we will come to know what does it mean in the circular economy when we talk about inner circle. Then we talk about circling longer. We talk about cascade use across, and you can see the difference in dollar value, how much the dollar was degraded, and we will come to understand what does that mean. And then the last one, we talk about separate inputs and designs. In the first one, in the inner circle, what we mean by that, we mean that the closer the loop, the higher the retained value. The smaller loops preserve more value and more. What does that mean? One require less energy. This means that we try to have the source, which is the water, in a very small closer loop in order to make sure that we don't lose the value of the water in a different, as a different commodity. We keep the water as a water as much as we can. And in the second one, when we talk about the circling, it means if you look at how many circles we try to maintain inside the circle, we talk about the function. We need to reduce the need for a new source. So we have the same source or the same cubic meter of water, and we need to use it as much as you can. And then if we are talking about the cascade, it's the transformation of the water from the water to a different material. But the more we transfer the water to an energy or to another source, the more we are losing some money. At the beginning, the blue arrow, which means like the highest value of the water when we start to take the water as a water. But if we keep changing the water into a different multiple sequential applications, like in a different manner, the water will stay in the circle of the life cycle, but then it will start to lose its value. And the last one is like how to avoid contaminating the water from having different hazards. I'll give some like a glimpse about the circular economy in Australia. The last report from 2025 shows that Australia has almost 4.6 of whole resources. Of course, there is a difference between one source and another, one material and another, but the total average of the circularity rate in Australia is 4.6. If you look at this number, probably it's lower than the average number in Europe and everywhere. And there is a reason behind this. Normally, Australia's circularity is lower than the global average of around 7%. That's the average. But in Australia, it's almost like 4.6. The main reason why Australia has lower circular economy because Australia has high virgin raw materials that have been exported to different countries. So as a provider of primary material to the world, Australia produces really huge amount of the waste, such as mine tailing, while they are trying to produce materials, and then they export these materials to other countries. So the circularity of this one will try to be, in contrast to the European Union countries, where they receive more of their primary sources as coming from the as imported one. So countries that export large quantities of primary resources generally have lower circular rate, which is very common. When we have our primary materials, we produce it, we are more likely to produce waste, and we are less recycling compared to some other countries who are gaining their resources from import resources, and they don't have any waste coming out. Now, what Australia did, actually, they paid attention to this area, and they started to move from material production to service production. And this graph shows us the difference between the GDP and the material footprint. Since 1997 until probably, I'll just give the first one, until 1980s, the amount of material that we produce and we extract, it actually was translated as a GDP for the country. When Australia started to shift, which is around 20,000, it started to shift to a service country. The GDP kept growing, but the material we are accessing, or the raw material that Australia is using, it's going to downwards. What does that mean? That Australia stopped accessing and reusing and exploiting materials from the source, and they moved to a different era of economical phase, which is more likely reliant on the service. So the material use, as we can see, there is a difference and the gap between the material footprint and the GDP. The GDP is still kept rising because we are providing services, and we have risk dependence on the materials itself. And this is, I think, one of the areas that most of the countries are started to access with the AI and with the generation of the new technologies. It started to grow the GDP without using or exploiting some of the resources. This is a graph of how is the...
Sorry, you have 2 minutes, please. 2
Okay,
minutes, please.
I'll go to my survey. The survey we did is actually about studying the barriers and opportunities of the circular economy in Australia. We had more than 200, around 220 participants, including expert judgment from these different categories: experts, academic, water utility, Queensland Water, and water industry. The survey was conducted in 2023. And the reason why we had this survey, we wanted to ask about the main top 10 challenges like what is holding Australia back from going to circular. And we found that there are 10 challenges. The main challenge was the impact of natural environment. People think that probably we are exploiting the environment. And there are so many different other factors. I'm just highlighting the policy because it's interesting. The policy wasn't highlighted as a main challenge, the policy and regulations. But if we look at the next question, we were asking about the options for solution to the circular water economy. And we found that if we improve the policy and the regulations, this will exceed and accelerate the implementation of the circular economy. There are so many different factors, but policies and regulations were one of the top. Then we ask about the barriers which is prohibiting us from transition to, or Queensland in specific, to be translated or transition to the circular economy. Policies and regulations was one of the top factors. There are so many different factors that holding back the circular economy transition in Queensland. Then there was inside the survey there was kind of the water use, like what the community perception on the water use towards the circular economy transition in Queensland. We find that people think that we can use the circular economy in anything, but not in the drinking. So there was so much interest in having the circular water in different uses, but not in the drinking water, which is very justified and very understandable. The summary of this key finding, I didn't present all of these things, but I'm more than happy to share the results later on. We are talking about problem solutions and barriers and gains, and we found that the main problem is the impact on the environment, the cost, the circularity. Solutions is partnering, education, responsibility, efficiency, policy, regulations, and others. If we want to conclude, we can conclude that circular economy, even in Australia, is still facing some challenges. I think one of the ignored challenge is the public perception and social acceptance to the circular economy concept. I don't think we have more awareness about what circular economy means. Probably for scientists and for some academics and researchers, it's a bright future, but we haven't been able to communicate the benefit and ensure that the community and the social aspects of this one is being really addressed in terms of the study. And I think that's one of the key challenge that we are all as engineers always ignore. We are very much heavily focusing on science, on equations, in math, in lab, in materials, in modeling, but we ignore the social sides most of the time, which actually has shown that it is a main aspect that we probably need to address and work more in order to make good connection with the community and society in terms of understanding what is the circular economy perception for the society. Thank you very much, and apologies for taking more time than should be.
Yeah, thank you so much, Dr. Ziad, for this interesting presentation. And now we move to the next speaker, Ms. Kauthar Mikni. And Ms. Kauthar, she's the CEO and founder of Key Sustainova Consulting from Tunisia. So the floor is yours, Ms. Kauthar, and you have 12 minutes, please.
Okay, please, can you share? Thank you. So, hello everyone. Thank you to the Global Ambassadors of Sustainability for this opportunity. Today, I will talk about the circular economy, waste management, and the key role of green project management in sustainable transition. I'm Kauthar Bekni, consultant in green project management. So the goal of this presentation is to show how we can move from a linear model to a more sustainable circular model. So please, we will move to the second slide. Today our economy still follows a linear model: produce, consume, and throw away. However, this system is no longer sustainable because resources are limited and waste is increasing rapidly. That's why we need a more sustainable and efficient model. In the next slide, we will begin by understanding the traditional economic model known as the linear economy. The third slide. First, this model is based on a sample sequence: take, make, and dispose. First, we extract the natural resources from the environment. These resources are then transformed through production process into goods and products. After that, these products are consumed by users. And finally, once they reach the end of their life cycle, they are discarded as waste. At first glance, this model may seem efficient. However, it is built on a critical assumption that the natural resources are abundant and unlimited. In reality, this is not the case. As a result, the linear economy leads to resource depletion, high level of waste, and significant environmental impact. For these reasons, this model is no longer sustainable in the long term. In the fourth slide, we will move to the circular economy, which represents a more sustainable and regenerative economic model. Unlike the linear model, the circular economy is designed to reduce waste to a minimum and to keep resources in use for as long as possible. It is built around four key principles: reduce, reuse, recycle, and recover. First, reduce means minimizing the use of raw materials and energy from the beginning by designing more efficient and sustainable products. Then reuse focuses on extending the lifespan of products by repairing, sharing, or reusing them instead of discarding them. Recycle involves transforming waste into new materials, allowing it to re-enter the production cycle. Finally, recover refers to extracting value from waste that cannot be recycled, such as as a result, it not only reduces the environmental impact, but also improve to better understand
Sorry, Ms. Kauthar, we can't hear you well. So I think we can't hear Ms. Kauthar. So maybe we move to the next speaker, and if Ms. Kauthar can come back later when she has a better connection. So the next speaker will be Dr. Abdel Fattah Mahmoud. And Dr. Abdel Fattah is a consultant and a lecturer from Egypt. So the floor is yours, Dr. Abdel Fattah.
Hi, everyone. I'm very happy to be here with you. We're talking about a very important subject like construction. Okay. Construction waste is a model of circular economy. Circular economy, it's mean how to use a maximum uses for the resource and the minimum wastes. How to generate this. So we're talking about a construction. Construction is the most economy or most effective sector in Egyptian national economy, and we have many new cities for this way. So we have some kind of effective or effect about the construction section, like process of this process, and we have wastes, many wastes of this. These wastes, it have these wastes, and its effect is a very problem way in the environment. It have a negative impact in this in our environment. So we increase the project, we increase the cost for get rid of these wastes in many times. Solid wastes is a usual include industrial wastes, medical, and another. But in this case, with construction, as finally have heterogeneous many wastes like plastics and paper and wood and many wastes. These wastes can be used as a source or resources for a new economic effect, like we can restore that energy from it or reuse it and have many green jobs for collecting and reuse of this. So it will have some kind of impact or social impact in our world. The cost of construction material increase daily because we have some kind of waste shortage and in the raw materials and how to get rid of these wastes. So we can use this waste as a new product or green products as a raw material. Like bricks, we have many types. I told talking about many types of these wastes, like bricks, wood, and concrete rebels, and recycled plastics, and the material or metals or many different metals. How to use it? We can have some kind of scheme of this process, like collecting it, and we will crushing or resize this and have a sieving process, then washing it and drying or let it air drying to be backing again. We can have many wastes how to use it or reuse it as a bricks or as a demolition in the buildings and ways and many uses for this. Thank you.
Yeah, thank you so much, Dr. Abdel Fattah, for this um, interesting presentation. And I think now we can go back to Ms. Kauthar to continue her presentation, and hopefully we can hear her but better.
Okay, I'm so sorry. Now to better understand the shift we are talking about, let's directly compare the linear economy and the circular economy. The linear economy is based on a disposal system, while the circular economy is regenerative. So overall, this comparison clearly shows that the circular economy is not just an alternative, but a necessary evolution of our current system. So at this point, let's move to the next slide. So we may ask, why do we call it a circular economy? To answer this question, first, in a circular economy, resources remain within the system for as long as possible. Instead of being discarded after a single use. Second, what we usually consider as waste is no longer seen as useless. Here we can say that waste becomes a valuable resource that can be reused, recycled, or recovered. Finally, the entire system operates in a closed loop where materials continuously follow cycles of use, reuse, and regeneration. So this philosophy is at the core of the circular economy and represents a fundamental shift in the way we produce and use. The next slide, we will explore the main advantages of circular economy. First of all, one of the most important benefits is waste reduction. So second, the circular economy promotes resource efficiency, and another key advantage is innovation. This model encourages companies to rethink product design, develop new business model, and adapt more sustainable technologies. In addition, it contributes to the creation of green jobs. So new opportunities emerge in areas such as recycling, repair, sustainable design, and environmental services. Finally, the circular economy strength is economic resilience. So by reducing dependence on scarce resources and volatile markets, it helps economies become more stable and adaptable in the long term. The next slide. It's about the challenges. So while the circular economy offers many benefits, it's also important to know its challenges and limitations. First, one of the main barriers is the high initial investment. Second is there is the issue of implementation complexity. The other key challenge is the need for culture change. Both businesses and consumers must adapt their behavior, moving away from use and dispose mindset toward more responsible consumption patterns. So finally, there is often a lack of infrastructure. So while the circular economy is promising, its success depends on overcoming the structural, financial, and behavioral challenge. So the next slide, to better understand the potential of circular economy, let's analyze the using SWOT framework. The SWOT analysis shows that the circular economy has strong advantages such as sustainability, innovation, and cost reduction. However, it also faces challenges like high investment cost and resilience to change. New technologies and green regulations create important opportunities for growth. There can also be limited funding, especially for small businesses and or developing economies. And in some regions, weak regulatory frameworks may slow down the implementation of circular initiative. The next slide, we will discuss about the important it's important to clearly distinguish between waste management and circular economy, as these two concepts are often confused. Waste management focuses on treating waste after after it's created. The circular economy goes further by preventive waste from the beginning, craft better design and resource use. So we can say that waste management it's a part of a circular economy, but the circular economy goes much further by addressing the root cause of waste. And the next slide.
2 minutes, please.
Okay. So let's explore the role of sustainable development in the circular economy. That it is based on three pillars: environmental, economic, and social. The circular economy supports these three dimensions by reducing environmental impact, creating economic value, and generating social benefits. So the next slide. Before introducing green project management, it is important to understand the fundamentals of traditional project management. It mainly focuses on cost, time, and the quality. Project success is measured by operational performance, often without considering environmental or social impact. And this exactly where the need for a more sustainable approach emerges. The next slide, we will move to green project management, which represents an evolution of traditional project management. So the green project management is no longer the project management is no longer evaluated or only based on its performance, but green project management is evaluated by overall impact on the environmental and society. So if we can compare green project management goes beyond the cost, time, and the quality. It integrates the three additional the dimensions: environmental impact, social responsibility, and sustainability. So, in other words, green project management transforms the way we design and deliver projects by aligning them with sustainability goals. So the next slide, the role of green project management in circular economy. So it is important for successfully implementing circular economy initiative. First, it helps in planning circular projects in a structured and efficient way by integrating sustainability objectives from the very beginning. Second, it ensures resources optimization by promoting better use of materials, energy, and the process throughout the project life cycle. It also plays a key role in reducing risks, especially environmental and operational risks, by anticipating challenges and implementing appropriate mitigation strategies. So to conclude, let's say the circular economy is no longer an option. It is the future. So it is the future for addressing environmental and resource challenges, but good ideas alone are not enough. Projects must also be managed effectively. So green project management is therefore the key to turning sustainable idea into real impact. So the transition to a circular economy does not depend only on ideas, but it depends on the ability to manage sustainable project management. So thank you for your attention.
Thank you so much, Ms. Kauthar, for the enlightening presentation. And we move now to the next speaker, Ms. Nahid Beiruti. And Ms. Nahid, she's an architect and university lecturer and master practitioner in NLP from Tunisia. So the floor is yours, Ms. Nahid, and you have 12 minutes, please.
Thank you, and good afternoon for everyone. Today I'm pleased to present our work. This presentation explores how we can reshape the way we think and design buildings. It introduces an evolving vision of building design and establishes a new design mindset. To begin, let us first understand why traditional approaches are no longer enough. Historically, circular economy strategies in construction focus mainly on material reuse, waste reduction, and recycling. These approaches remain essential. However, they are not sufficient on their own. True circularity requires a deeper transformation. Buildings should no longer be designed as fixed and permanent objects. Instead, they should be conceived and adaptable systems that can evolve, change function, and support multiple life cycles over time. This idea leads us toward a new understanding of architecture. Circularity in architecture is not simply about recycling materials. It represents a fundamental change in how buildings are conceived from the very beginning. A circular building is designed while considering its entire life cycle. This means anticipating maintenance needs, future adaptation, material recovery, and eventual transformation. Circularity, therefore, become design culture rather than a technical solution. Now let us explore practical strategies that can integrate it during the design phase. The first strategy is designing buildings that can evolve over time. Spaces should remain flexible enough to accommodate future needs. For example, office spaces could later become residential units without major structural interventions. Another approach involves extensible framework. Building can be designed to allow future vertical or horizontal expansion. Finally, shared use spaces improve efficiency and reduce unnecessary construction. These strategies increase adaptability and support long-term circularity. Flexibility is important, but building also should be designed for future recovery. An important principle of circular construction is designing building for disassembly. Instead of permanent assemblies, buildings should use modular components and reversible connection. This allows materials and components to be removed without damage. Alongside construction methods, material selection also plays a major role. Choosing sustainable materials contributes both to building durability and environmental protection. Material selection should consider long-term impact on ecosystem and resource efficiency. Another important tool is also life cycle analysis. It helps evaluate environmental impact and estimate future recovery potential. Beyond design decision, construction practices themselves must also evolve. So construction processes generate significant environmental impacts. Circular approach therefore encourage cleaner method and optimizes logistics. Prefabrication reduce on-site waste and improve quality control. Optimizes transportation, minimizes unnecessary movement and emissions, and efficient cutting strategy reduce material loss. Construction site can also become a place of resource recovery. So circular construction encourage viewer material as valuable resource rather than waste. So inside the sorting system help recover reusable materials. Shared equipment reduced duplication and improve efficiency. These practices strengthen resources management while minimizing environmental impact. Another important principle concerns how buildings are physically organized. So buildings contain layers with different lifespans. Structural systems generally last much longer than finishes or technical installation. Circular design encourages separating these layers. This separation allows future modification without affecting the building's structural integrity. As a result, the buildings remain adaptable while reducing demolition waste. Once buildings are constructed, maintaining them properly becomes essential. The operational phase plays a critical role in preserving building value. So smart monitoring system improve resource management. Preventive maintenance also extends component lifespan. Rather than replacing elements prematurely, Circular approaches encourage long-term switch-shift. This maximizes resource efficiency and preserves future recovery potentials. Eventually, every building reaches the end of its operational phase. In circular construction, end of life does not mean end of value. Instead, it represents the beginning of a new cycle. Selective deconstruction allows materials to be recovered carefully. Separating building layers preserves component quality, and recovered resource can then re-enter future construction system. Demolition therefore becomes transformation rather than waste production. This principle ultimately leads toward broader transformation of architecture culture. And this diagram summarizes how circular thinking accompanies building throughout their entire life cycle. From design to construction, operation, and deconstruction, each phase contributes to preserving resource and maximizing long-term value. This evolution also transformed the architect's role. Architects today are no longer only designer of physical forms. They become designer of transformation, adaptability, and resource cycle. Designing a building now means anticipating future evolution. Buildings should remain capable of changing function, adapting to new needs, and preserving value over time. Finally, let us conclude with the broader implication. So transforming the building sector requires more than technical improvement. It requires a culture transformation. Architects, engineers, builders, and clients must collectively rethink how buildings are designed and managed. By embedding circular principle across all phases, we can reduce emissions, improve resilience, preserve resources, and create a more sustainable built environment. So thank you very much for your attention. Thank you.
Yeah, thank you so much, Snahid. Another interesting presentation. And now we move to the next speaker, Ms. Fadia Obaid Shakir. And Ms. Fadia, she's the founder and principal of FOC Design from Lebanon. So the floor is yours, Ms. Fadia, and you have 12 minutes.
Thank you, Dr. Wissam Michel, for having me. So I will be talking about lime plaster as a sustainable material for modern construction. So as we all know, the construction industry, they use around 60%, if not more, of global cement, not to mention the steel, aluminum, and plastic. They consume 40% of raw materials. It consumes around 40% of energy, 60% of global water resources. So when we talk about developed countries, we know that 50% of this total energy is linked to construction, operation, and building maintenance, which is this industrial sector generates approximately 40% of CO2 emissions, and largely is or mostly from manufacturing processes. So the environmental impact from cement and steel is large. So global cement demand, especially in residential construction, is projected to reach around 900 million tons by 2100. And cement and steel industries produce approximately 14% of global CO2 emissions. This demand for this material is expected to increase by 27% in 2050 due to industrial growth and urbanization. So to reduce this CO2 emissions and to it's very challenging actually, especially that all these productions need or relies on high temperature, on energy intensive and chemical processes. So why I'm starting with the construction, cement, and all of these elements, because I want to say that and talk about Lebanon specifically, because we all know what happened in August 4, 2020, when a large non-nuclear explosion happens in Lebanon, when 2,750 tons of ammonium nitrate detonated in the port of Beirut. And the ongoing war in Lebanon, which didn't stop till now, especially then in February, I wanted to show in video before and after, but this is a still image. So we can see how much villages, especially in the south of Lebanon, was deteriorated and destroyed, a lot of damages, and especially the historical houses or homes, buildings, which is more than 200 years old. So we have to think about the construction of reconstruction of these building in Lebanon, which is we know that it will be very actually a cheap one. Why? Because they want to do it fast and they want to use the easiest way, which is the cement and all these imported materials, which affect basically on, especially on the heritage buildings and houses. And this is actually, it will be a disaster because all these beautiful heritage houses need to be treated in a different way. Lime plaster, why I choose the lime plaster as a sustainable material to talk about, because this is one of my topics of my research that I'm working on at the moment. So if I want to go back historically about the lime plaster from the hunter-gatherers, it was used back then, 17,000 years ago. It also began thousands of years before Neolithical farming innovation. At Nahal Ain Jaf, a 12-year-old cemetery was discovered beneath high-quality pyrogenic lime plaster. The findings showed that large-scale lime plaster production began 2,000 years earlier than previously believed, reshaping the history of plaster technology. So also, Hayonim Cave provides evidence of quick lime production as early as 10,000 CE. Sorry, I hear voice sounds. I don't know if okay, thank you so much. All right, so why is lime plaster important? Traditional lime, if you want to talk about traditional lime, is a low carbon and climate responsive building material. It is considered a sustainable alternative for modern construction and restoration. It is also evaluated through life cycle assessment, which demonstrate that through its life cycle, it generates lower CO2 emissions. Also, lime supports sustainable reconstruction and heritage-compatible development. It is increasingly recognized by architects, industry professionals, and communities. So if we want to go back to these old, most renowned architectural building that used, aside from mud and earth, lime is one of the material that they use in Giza, Egypt, and Pantheon, Rome, Taj Mahal, India, Great Wall of China, and many more. So to go back to Lebanon vernacular architecture, we know that Lebanon has went through different eras, different phases from late Ottoman to early French Mandate period. This period, although the style was different from a style of building from an era to another, or from a period to another, but still we see that the triple arch facades and the limestone exist in all these buildings. It can be from lime plaster to paint using lime. And still till now, these buildings still have in a good shape actually. These are some of the houses that we see that from French Mandate period, or and it's different from we see on the coastal. It's different style than in the mountains or on the south of Lebanon. These pictures were all took by me actually. These old houses where you can see there is always a common thing in the design, but still the limestone and the lime plaster everywhere you see in the beach area or on the mountains. How it is produced. So the lime, it's like a jar or a pit where we can, it has a diameter of 3 meter, around 3 meter, depth 8 to 15 meter. And the design allows to efficient heat retention and control calcination. So all these pictures also were took by me, so you can see how it look like, and it's all built of limestone, plaster from inside, and there is the fire opening, which is on the bottom of this kiln. So this is how we see it. This is the fire on the fire oven on the right side. When start burning, this is how that we have the lime plaster eventually. So we can see here I was here with Mr. Fawaz, who's I guess the only one still working in Lebanon in lime plaster. So after the burning process, here you can see that it became like a powder, where if it is mixed with the water, so we can have the lime and also lime putty consistent is adjusted by adding additional limestone if needed to have a lime putty. So the mixture is stirred every 2 to 3 days to ensure homogeneity and prevent unreacted particles. Airtight storage is essential to prevent material degradation and loss of effectiveness. This is very important. So lime production begins with the calcination of limestone. This is how it happens. This is how the kiln or the limestone jar looks like. It looks like a jar actually. Then it's the producing quicklime, which is CaO, and releasing CO2. Efficient calcination occurs at 1000 degrees Celsius overheating. The result is an inactive, dead burned lime, we say. So traditional kilns retain heat using earth or stone insulation, ensuring throughout the calcination. And after cooling, quicklime is manually extracted and prepared for slacking. So lime is a calcium-based material, as I said. It's go under calcination, hydration, and carbonation. Lime mortars are flexible and vapor permeable, crack tolerant compared to cement. Lime plaster and lime wash regulate humidity, improve indoor comfort, act as a sacrificial and protective finishes. So it has a alkalinity which is pH around 12 to 13, which is antimicrobial and antifungal protection. This is the most important thing. So it has a very low VOC. Preservation of timber and organic elements. Actually, it's zero VOC. Preservation and timber and organic elements. So we can use it as a paint, which is breathable. So mortar and plaster, how it's applied. If it's mixed with sand and water, we can have mortar and plaster. Lime wash finishes if we just add water. Sterilizing agent and stabilizer if a small amount of sea salt can be added to improve hardness. Also, study confirmed that dual-sided lime plastering significantly reduces interior condensation. I will mention again that all these pictures were taken by me. This is one of the oldest buildings in Lebanon, in Shuf, in year 1626. So as you can see, it's limestone, plastered with lime, and painted with lime. So it's essential for lime is it represents embedded ecological knowledge and craftsmanship essential for heritage conservation, material compatibility and restoration. It supports minimal intervention strategies like stabilization and prevention of further deterioration. We know that in Lebanon, a lot of earthquake happened, a lot of wars. So it went through a lot, these houses, and still can maintain to have this shape and plaster and still in a good condition, actually. Support, as I said, reinforce the link between material culture, resilience, and sustainability. So this is one of the castles in Shuf. In this picture, you can see the vault, interior vault made of limestone from inside. Lime function as more than a binder. It regulates indoor climate, protected masonry, prolonged plaster lifespan. It has low environmental impact, reversibility and compatibility with stone masonry, lower embedded energy than Portland cement. Lime reflects also 13% more light than gypsum, support passive solar and visual comfort strategy. This is a house that I took from outside, and from inside you see the lime plaster and lime paint from inside, whereas from outside it's just a grout and limestone made of lime. The one that I was talking about, the Palace of Hussein Hamidi, built in 1591. The lime plaster, or if we want to do lime wash, we can add organic material like sand or clay to change the color. Even we can change the color with plants. The humidity is huge, especially that it can occur 90% of the time, 60% of the year actually. And with the lime plaster or the lime wash, this is because it's breathable, and of course we can prevent humidity, and this is why it's important, and this is why I said it's zero VOC. Through the life cycle assessment, we see that the lime-based material gradually absorbs CO2 via carbonation over the service life, partially offsetting initial emissions and contributing to a more balanced through not fully carbon neutral life cycle. So it absorbs CO2 and it releases CO2, but somehow it's not zero, but at least it is less CO2 emission than other through its life cycle. I mean, because we know that once we are producing the limestone, the lime plaster, it go through this the LCA. So durability and repairability, lime plaster last longer, are easy to repair, do not require full replacement, whereas cement, crack, trap moisture, require demolishing and rebuilding. Of course, we cannot prevent using cement, especially for fast construction, but when we can use lime plaster, it is better to use lime plaster or lime wash, or to have at least a more balanced or more environmental friendly material. So that's all.
Okay, thank you so much, Ms. Fadia, for this interesting presentation. And now I'm inviting Michelle and Hajra to moderate the Q&A session. So the floor is yours.
Thank you so much. And thank you to our speakers today. And a huge thank you to all of our people in the audience asking such thoughtful questions. We will get right into it. We're going to start with you, Dr. Ziad. And we have a question. Our first question will be from Indira Bunik from Switzerland. And Indira asks, smart infrastructure is often discussed as a solution to urban sustainability challenges, but what are the critical preconditions that, whether they be technical, financial, institutional, that cities must first have in place before smart infrastructure investments can truly deliver resilient outcomes? And if possible, to keep it around a minute, that would be fantastic.
Thank you. Probably I'm going to be surprising Indira, when we say smart, actually, we have to identify smart. Now, the coming research showed that when we talk about sustainable cities or sustainable infrastructure, this is not enough, because the research has proved that there is a good relationship, contradicting relationship sometimes, between sustainability, smartness, and resilience. And if we want to design for the smart infrastructure, I think we need to incorporate both the resilience and the sustainability aspects of the smart infrastructure, because it shows, like the evidence shows, that smart, it doesn't mean necessary to mean sustainable or resilient. We've got a paper published in the Journal of Clean Production, where we identified the three pillars of cities, and the relationship between smartness, resilience, and sustainability. I'm going to put the link for this publication in the chat, because it might give you a further detail about what I mean by this one. But definitely, we are not talking about one element here to stop as a barrier. It's not only the cost, it's not the public perception. We are living in a evolving world where the technology is fast growing more than the absorption capacity of the human. The curve we are looking at is not like an exceeding curve. It's becoming like a vertical line now with the AI and the introduction. So I think technology is the first thing now. How we understand and how we still control the technology, that's the first thing. And then how we interpret the data. Smart infrastructure can provide us with so many data, but the main problem is not with the data, it's about how we are analyzing the data and can respond to the data that we receive. Thank you.
Thank you so much, Doctor. And our next question will be for Engineer Nahed. And then Hajra will ask our next question to Ms. Fadia. But we have Ihab Wage asked the question, how does evolutionary and extensible design practically reduce long-term redevelopment costs compared to traditional static design approaches?
Thank you for the question. Evolutionary and extensible design reduce long-term redevelopment cost by allowing building to adapt, expand, or change function in the future or over time, avoiding costly demolition or major renovation and material waste. Thank you.
Thank you so much. And Hajra, I'll let you jump in.
Yes, perfect. So this next question is for Dr. Fadia. The question is from Zuhair Ibtisam, also known as Strong Truth. The question is, do you believe zero waste reconstruction can become a mainstream within the next decade? Why or why not?
I don't think so. But we are working towards to have as much as we can to protect the environment through the material that we can say indigenous one that they used to do to use, because we find that this is the right way to start over. Actually, due to the fast construction and everything, I guess, and still till now, we cannot. We still rely on fuel. We still rely on a lot of materials that we try as much as we can to prevent it or to use it less, if we can say like this. But that's why I started with something that we used to use, which is the lime, because it has a lot of function that hopefully it can be useful for new construction, and for this modern construction, it can at least be a revolutionary material later on if we use it in the right way, and it can at least help. But hopefully, I mean, we all hope for that. But with all the wars that's happening around us, I don't think so.
Thank you so much, Dr. Fadia. And it's always good to be really honest about where we are and where we can
Actually,
really.
that I'm in the middle of that, so I can talk with lot of transparency.
Yes, thank you so much. And our next question is for Dr. Ziad. Um, George Florin asks and states that you highlighted that Australia's circular yearly rate is only around 4.6%, below the global average, which is 7%. In your view, what are the most effective policy instruments that governments can use to accelerate circularity in resource exporting economies without negatively affecting economic competitiveness and employment?
That's a very good question. The government has done lots of things and the policy has been updated. The main issue with Australia is the wide spread of its geography and the population growth. We've got like really high population growth like rate compared to other countries in the region. But the main aspect is that Australia is full with raw materials and minerals, and mining is the main resource of industry here. And when you talk about mining, you talk about like really huge tons of waste that is being generated in order to extract the main resources before you export it. So you export the pure material and you end up with a waste. So whatever you are doing in terms of recycling or using or circularity aspects, you're still behind because your main pure resources has been exported out. So the ratio is unbalanced because you've got the waste remaining in your country, and that's why, by the way, Australia is surprisingly, Australia is one of the top best countries in exporting waste to China and Malaysia. There is kind of politics nowadays with China, but the reason why the waste was exported is just because we want to accelerate and increase this one. But there's enough, I would say, not very much, but there should be like a room to improve. But the policy and regulations is okay. But Australia is unlucky because of the geography, the area, and the population rate here.
Yeah, thank you so much. And great question. I know in the United States, we had the same situation of exporting our waste. And so similar situation there. For those who may be new, you will see a QR code up on the screen. And we just want to let you know that if you scan the QR code, you can take a quiz for today's program and receive a certificate. And again, if you haven't done the prior 6 modules, this will be a 12-part series. You are welcome to go back and do them at any point, and you can get each of the different certificates in the full fellowship if you complete all 12. And I will pass it to you, Hajra, to ask the next question.
Perfect. Thank you so much, Michelle. This next question is for Engineer Nahid. This is from Faisal Afridi. The question is, what business models, examples like material as a service, component leasing, best drive the shift from linear to circular building systems?
Thank you. The most effective models, I think, that include materials as service, component leasing, product service system, because they encourage reuse, maintenance, adaptability, and resource efficiency. And so that they support the transition from linear to circular building system.
Thank you so much. And I think we'll do one question for everyone. And again, just kind of rapid fire to answer them because I know we have about 5 minutes left. So a question that Dr. Indira has asked, a message to the next generation. If each of you could leave this fellowship cohort with one non-negotiable principle to carry into their sustainability leadership careers, what would that be? And we'll start with you. Whoever would like to jump in if you have a quick answer, but if not, we'll start with you, Dr. Fadia.
Can you please repeat the question? Non-negotiable. Can you please repeat the question? I didn't hear it well.
Yes. So a message to the next generation, if each of you could leave this fellowship cohort with one non-negotiable principle to carry into their sustainability leadership careers, what would that be? One non-negotiable principle to carry into their sustainability leadership careers.
I guess I said it already, but maybe non-negotiable sustainable leadership. So what can I say? What can I say? For example, no. And I think the I don't know if I understand it clearly, but I will say that each one of us, I think the way of life, the way that we have to live, the way that it has to change in a way, the mindset, I guess it has to change. So eventually, if we, as I said, if we go back a little bit to the way they were living before, the way that they if we start from our home, if we start from everything we do on a daily basis, so I guess a lot of things we can change, from recycling, from reusing the same material, from using organic stuff. I don't know if I understand well what you're saying, but if this is this is what you mean. So and how we can start it in our daily routine. So I guess it will come up in a very easy way of living, I guess, and easy. I don't know, and I don't know if this is what you were asking about. So.
No, I think that's great. I think the mindset is definitely the place to start. And that's where so many of our speakers in the past have always said, if we don't have that sustainability mindset, then we can't transition anything. And if we can't encourage other people to do that within their daily lives, then certainly they're not going to take it into their career. So I think that's a brilliant answer.
Because a lot of people talk about sustainability, but eventually they are not using it, they're not implementing it in their daily routine life. So I guess we have to start from the smallest thing that we do on a daily basis, and I guess people will change eventually when they see what the others are doing. But if we want to talk about sustainability on a global level, and then we see what's happening in the world, so I don't know, yani, we are contradicting ourselves.
Yeah, thank you so much. And Engineer Nayed or Dr. Ziad?
Go, Dr. Nayed.
Okay, thank you. So for me, the main subject that of my presentation, that we must today think from the start for the future, not just for the present. So we have to change thinking, to change our mindset.
Thank you so very much. And Dr. Ziad?
I would say very much I would totally agree with what my colleagues here said, but I would say you have to be having really critical thinking. Not every shining thing is a gold. Sustainability as a concept should be like in every daily aspect as a system, not as like a small thing. But in the same time, we need to think about anything that we have. I will give an example. Everyone is talking about AI, how good and how really perfect AI. AI is contradicting to the sustainability. if you think about how much energy do we need in order to run and process all these huge mega computers that we are talking about in Tesla, in IT, we are using so much water. And the relationship between this IT and this AI and the water as a source is ignored. And it is ignored for a purpose. My point here for any leader is that you need to think as a system. You need to connect. There are so many good benefits from AI, but if you don't know the, let's say, the dark side of the AI, it means like you just take the surface. Go deep, think critical, and believe that there are so many different things beyond any thing. Even sustainability now, probably after a few years, we will start to talk about the disadvantage of being sustainable, not smart or not resilient. So critical thinking and go deep. Ask the root cause of this one. The 5 whys rule always work very well.
Thank you so much, Doctor. And I'll say, I know that Hajra works with us to do a lot of the interview process for our collective team, and that is like our number one question. And if we can't get past critical thinking and have clear examples of how people are even implementing that within their work, because it's
Michelle,
not common.
So sorry, the last one I saw a question by George about how the wastewater can be generating circular economy while we are having a nutrients recovery. I think this is a good example of why I'm talking about critical thinking. We are having wastewater treatment plants where we have a tertiary treatment in order to treat the phosphorus and nitrogen. And then we go and we look at the nature, how to extract phosphorus and nitrogen as a compost or for our plant and nutrient. We have rich source of phosphorus and nutrient. We just need a small process like oxidation or neutralization and take them away from the middle of the process. But we leave them until the last minute, and then we ask for a new way how to treat and remediate the phosphorus and nitrogen. So the nutrients are there. We can extract them from the middle of the process in a simple way physically, but we'd rather make them as a problem, and then we look at how we can retain them in the system from the last part of it. But thank you.
Absolutely. Thank you so very much. And I know I'll let Dr. Sam share what's up on the screen right now, but I want to, I'll pass it over to him. But I want to say thank you to our speakers today. Thank you to our audience. This is the most informed audience. This program would not be able to take place in the way that it does at the level without our partners. Each of you that are out there in the audience are our collective partners. Many of you have been our speakers. There's such a high level of understanding that are going into these questions and the comments that are on there. So we are forever grateful. And I want to give a shout out to our team, Hajra, for doing all of the management of questions, as well as some of the presentations on the back end and promotion, as well as Jane and Natasha, who also helped put everything together and helped to promote. So thank you to our team. And back to you, Dr. Wissam.
Yeah, thank you so much, Michelle and Hajra, for moderating the Q&A session. And again, I'd like to thank the guest speakers for today, for their enlightening presentation, and for the audience for their engagement and the active participation as usual. And as you can see, we have at least the audience coming from 34 countries. And you see the diversity from Southeast Asia to North America to Australia to, like, we are, as one of the colleagues first said, like, this is the Assembly of United Nations. So everybody is being represented. And we are very proud of this program. We are very proud of our guest speakers, our audience. And we really feel that we are creating an impact. And again, with the discussion, with a lot of these case studies and the sharing of knowledge from the academic perspective, the industry, and also the non-profit. So I think this is the uniqueness of this program, this fellowship. And we yeah, we will continue with our partners, as Michelle said, and we consider all of you as our partners of this success story. So we'll continue this program, and we are developing a new program, another interesting program, which is will be the continuation of this fellowship program. So we'll keep you posted, and we'll see you in 2 weeks' time. I'm sorry, next week we'll have to take a break since it's the Eid, the celebration for the Muslim community. So we'll see you in 2 weeks' time in module number 8. So thank you so much and have a good time, everyone. Bye bye.
Thank you.
Thank
Thank
you.
you.
So much.
Thank you so much. Bye.
Bye.
Thank you, everyone. Now, how to exit?
Same problem.